So in this video, we are talking about the reflux ratio in the atmospheric distillation column. So reflux, we all know about the reflux. It is a liquid back into the column in the enriching section to maintain the vapor liquid interaction at each trace. So it looks like, for example, at the top, this is vapor. We have to condense the vapor, and then there are reflux drum where the liquid are stored. A portion of liquid is taken as distillate as product, and a portion is returned back to the distillation column for maintaining of the vapor liquid equilibrium. This amount, this is called the reflux. In the atmospheric distillation column, a reflux can be classified as top reflux and side reflux. In the top reflux, there are only one type, that is called the U-type reflux. In the side reflux, there are two types. One is pump around reflux and one is pump back reflux. Now we are going to discuss detail about these three types of the refluxes. Before that, this is the one of the very important thing, that is a temperature profile in the atmospheric distillation column. For example, this is the bottom, this is the bottom, and this is the top. So as far as the temperature profile is concerned, the top has, this is temperature, this is height from the top to bottom. So from the top to bottom, the temperature is increasing. From top to bottom, temperature is increasing. Say for example, if the temperature of this top is 100 degree Fahrenheit and at the bottom is 500 degree Fahrenheit, and so on. So this is the temperature profile in the any given column, atmospheric column. The second term, that is the pressure flow rate. Flow rate, how the flow rates are going on. This is the top, this is the bottom. So this is the flow rate of the material inside. So if you see, this is the top and this is the bottom. Also that should be the bottom. So at the bottom, all the products are there, means A, B, C, D. For example, if suppose this is A, product B, product C, product D. So all these products A, B, C, D will be available here, and here only A, B, C will be available because D is taken as. Here only A and B is there, here only A is there because B is taken from here, C is taken from here. So what it means, that at the bottom we have a very high amount of the stream, liquid stream, but when you go upward at the top level, the flow rate becomes lesser and lesser. So we can say this can be the flow rate profile. In any distillation column, top to bottom, from the top to bottom it is increasing. So these two things are very important for understanding the refluxes. Now come to the reflux. So the first one is the U-type reflux. So what it means, that in the U-type reflux, basically a vapor is taken from the top, condense it out, and heat is removed from the top. One product is taken as distillate and one portion is sent back as a reflux. So it implies only the top reflux from the overhead condenser for the partial heat removal. So this is the only section where we want to remove the heat from the complete distillation column. So this is the U-type tower, means that only the top reflux, that is called the U-type reflux. This type of unit is obviously impractical, since heat is removed only in the overhead condenser at a temperature level too low for the recovery of heat. So temperature level too low, because we know that temperature at the top is very low in the distillation column, lowest at the top. So at very low temperature you can recover only partial heat, not the complete heat recovery is possible. So heat available in this section is at high temperature, heat available in this section is low temperature, so only the very partial heat removal is possible. So secondary, the vapor liquid traffic throughout the column increases from bottom to top, which requires sizing the tower based on the existing flow at the top tray. So this is the second reason for this impractical, because vapor and liquid traffic will be very high. Since heat is not removed, so we have more and more vapors here. So that's why the sizing of the tower is required to recalculate for this purpose. So in short, if I say vapor is more and liquid is less, so vapor liquid traffic will be available, equilibrium will be disturbed. So in short, if I say U type reflux ratio is the inappropriate type of reflux ratio, we have to search for some solution. So what could be the solution? So that is the other options. Other options is heat removal at intermediate points, not only from the top, but heat removal means the refluxes at the intermediate point can be attained. How? With the withdrawing of the internal liquid streams, then cooling it and returning back to the columns. It means that we want to take out some liquid from the column, then we have to cool it, that liquid, and send back into the column, so that there will be no change in the mass transfer, but the heat will be changed, means there will be a heat removal process, that is called the reflux process. For example, one case is that we can take the liquid and then cool it and send back into the column. Second option, we can take the liquid, cool it, and send back into the column. These are the two options, basically possible options. Both are the same option. These two are the same options. So the cooling medium, that important thing for these things are, the cooling medium is usually the crude oil. That is important thing. What it means that cooling medium is crude oil, so which is being preheated before entering the furnaces. It means that in all these heat exchangers, in all these condensers, we want to take out these heat, because heat is removed from here, from all these places, heat is removed. So that heat could be utilized for the heating of the crude oil. So how it is possible? So it can be possible. For example, we can take, this is also, all these streams are basically, all these streams are crude oil. So crude oil being sent in all these condensers where it has to be heated out. So now this inlet temperature is lower, and this is the heated crude oil, So in this way we can collect all these crude oil at a higher temperature. So we can say a dual benefit is realized, means one benefit is to heat down the crude oil, the second benefit is to maintain the heat balance within the reflux. So how we can how this is possible? There are two ways. One is the pump around reflux base, that is called the type A. The second is a pump by reflux, that is a type R. So come to the type A reflux. It implies externally circulated and cooled stream at one or more side points on the tower for practical partial heat removal. So we can remove heat by using this method, that is the pump around method. What is going on? What happened? The liquid is withdrawn from the tray above the lower draw tray, cooled and returned to the tray further up in the tower, but below the upper draw tray. So it means that we have to make this whole story between the lower draw and between the two draw trays. I'll show you. This is a lower draw tray, this is the upper draw tray. We take a liquid from the above the lower draw tray, cool it, and then send back to the column below the upper draw tray. That is basically this is about the tray. So this is the A-type reflux. In normal practice, such a section generally uses 2 or 3 actual trays, including the pump around draw tray and the tray on which the cooled liquid returns to the tower. What it means that this is a tray, this is the first tray. Okay, this is the second tray. So this is a tray from where we are taking out the liquid. This is a tray from where we have to put the liquid. And there are sometimes third tray, that is between these two. So there are total 3 trays are involved. 3 trays are involved in this type of system. So that is the important thing. This technique is generally employed at a low and at the intermediate point in the tower and makes heat available to exchange again the crude oil at 2 different temperatures. So that is basically at different sections we have a different temperature, so we can utilize that heat for partial heating of the crude oil. This method has the advantages of stabilizing the vapor and reflux, true reflux liquid flow. So means there are throughout the sections where it is used, as well as significantly reduce the vapor and liquid traffic throughout the column. So that is the important thing. This is the advantages. It stabilizes the vapor and liquid flow, number 1. Number 2, it basically reduces the vapor liquid traffic throughout the column. The disadvantage of this method is that there are 3 trays normally used for the heat removal must be considered as only one actual tray. All these 3 trays are basically all these we have discussed these. There are one tray, second tray, and three. These three trays are considered as one tray for the fractionating purpose. So that is the problem basically. And this is because from equilibrium viewpoint, the pump around liquid is foreign to the zone in which it is employed. So that is the basic reason. What happened, this liquid that is being implied here, this liquid is totally disturbed this vapor liquid equilibrium in this tray and even this below tray. So overall you can say all these three tray are one tray with respect to the equilibrium fractionation. That's why that is the limitation. So this is one of the type, that is the A type. Now come to the pump back reflux, that is the type R. It implies subcooling of a true equilibrium liquid refluxes. Partial process heat removal is possible, and this is usually occurring at all side stream product draw point. So we can do it at all points. The most economical type R design use crude oil charge as the cooling medium. Same thing, that is we have to be utilize the crude oil for the heating of for the pump reflux stream, thus also obtain the benefit of the feed preheat. So that same thing is happen. It implies at all draw tray. There is the additional advantage that all liquid within the tower are true equilibrium reflux liquid, and thus all tray can be considered as being effective for the fractionation purposes. A fairly uniform vapor and liquid traffic exit in the overall section of the tower. So that is advantages here. Only one tray is involved, or you can say the each and every tray is used as effective fractionation purpose. Number one, almost very good vapor liquid traffic, basically very low vapor liquid traffic is there. So we can say there will be no problem vapor liquid traffic, and also the advantages for the proper refluxes are there also. Preheating of the crude oil is also possible. This is the one, for example, this is a draw tray, so we can take a portion of that tray, pull it and return back into the column just below the draw tray. Similarly, this is also the another draw tray. We take out the liquid and send back into the bottom of the sections. So there will be no difference, there will be no change in equilibrium or vapor liquid interaction. Similarly here also no change. Why no change? Because if suppose this material is always coming from this tray. This material is coming from this tray, going to this way and condense out and return back. So there will be no change, means there will be no foreign material. This is not treated as a foreign material. So that's why it is treated as a single tray for each fractionation purposes. So this is all about the R tray. In short, if you complete the side, all these are the intermediate refluxes. Type A or the type R, only a portion of the total heat removal is possible by these two techniques. Means you cannot remove 100% of the remaining portion of the removal must be satisfied from the condenser at the top tray. So it means that top condenser is always be there along with the intermediate refluxes. So top refluxes always will be integrated with the intermediate refluxes. So this is basically the concept of refluxes. The possible questions then can be possible in this reflux ratio section, that is discuss the difference between the refluxes used in atmospheric tower, why intermediate reflux are required in atmospheric column, how it can be applied, explain U type reflux, explain R type reflux in atmospheric with the help of Native sketch, explain A type reflux with the help of Native sketch, compare the RA refluxes applied in the atmospheric distillation column. So these are the possible questions. So this is all about the refluxes in atmospheric distillation column. Thank you very much.